Hey everybody, welcome back to Let's Get Defensive. This week, Andrew Sparrow has written our introduction. What you got, Andrew?
I try to come up with something that introduced the show in the same way for the 23rd week with the exact same joke. So, welcome everyone to this week's show. Wait, hold on. Are we sure we're in the right place? I thought this was the Home Shopping Network. I had a whole bit planned about how to get a lunar rover with 4 easy payments and free shipping to the moon. Guess I'll save that for next week.
Greg,
Well
do you feel like Andrew may not like the kind of intros we've been doing for the show recently?
I thought he enjoyed them, but apparently I'm wrong.
Yeah. I feel like we need to do some whole new thing now, just to kind of get
No, really?
Back to the drawing board.
All right, so welcome to Let's Get Defensive, the show where we get to talk about recent news in aerospace and defense. We get to discuss, debate, argue, and agree over what the best parts to focus on in the product lifecycle are. Coming up, U.S. Space Force, United Launch Alliance, NASA, SpaceX, Blue Origin, Safran, BAE Systems, Boeing, Saab, General Atomics, Electromagnetic Systems, Bombardier Defense, and Sierra Nevada Corporation. Here we go.
We got a lot going on. Let's start with ULA. The Vulcan Centaur rocket is about to make its grand debut. And guys, this look at it. It's not just any rocket. This is a new powerhouse for the U.S. Space Force's first mission with it. It's the Vulcan Centaur's maiden voyage, its first big test. Think of it as the rocket equivalent of a Broadway opening, right? But space. But the mission is national security. This isn't just about cool science. It's about keeping the U.S. ahead in the space race where the stakes are sky high. Brian, are you proud of me?
I see what you did there.
Yeah, it's made by United Launch Alliance, ULA. As we all know, a key player in the rocket business. They've spent years crafting this beast, and now it's time to prove they can hang with giants like SpaceX. The rocket's got some serious muscle. It's designed to carry heavy payloads, massive satellites, top secret gear straight into orbit, and then the tech. This thing is cutting edge, high performance engines, next gen design. I mean, take a rocket nerd. This is his dream coming true.
The number one challenge on this one is speed. It's time to launch for me. This isn't SpaceX. Don't forget, SpaceX are popping up these things hundreds a year. They're kind of pumping out these rockets like iPhones. Good old SpaceX. This Vulcan Centaur delays are what could put national security at risk. They've got to get it on time. A rocket that's late is a rocket that's frankly useless. So without slashing time to launch, Space Force could be stuck watching a kind of a Netflix instead of dominating the orbit. So they're going to have to get this right.
It is funny that you mentioned Netflix there, because I cannot hear the name Space Force without thinking of the show Space Force with Steve Carell, basically The Office, but for government. Space Force, right? Like it is hard to separate the joke of that with the reality that this thing actually exists, but it does, and it's a real thing. And in this case, I mean, the Vulcan Centaur, it's about to fly, and I know you said speed, Andrew, but I think the key here is actually going to be in transitioning the operations from one spacecraft that they've typically been using to another, which is the Vulcan, and making sure that the Vulcan's performance and versatility are evolving to meet these demands, which can definitely be ever changing. Like what's being sent up to space is changing quickly, right? So this has to be something that's versatile.
Yeah, or even versatility. I think this it's not an Amazon delivery drone we're tweaking here mid-flight. If Vulcan doesn't launch on time, then no one's going to care how versatile it is. Space Force is going to be kind of calling SpaceX faster than you can say BFR.
You know, I think in order, we know what your BFR stands for. Okay. I think in order to figure out how do you make this meet the right needs, and in order to figure out what you're talking about of how do we make this happen on time, which is one of the needs or one of the, shall we say, requirements, You've got to know how these requirements fit into your whole process, how they affect your design changes, how you decide which ones are worth the amount of effort that they take to make happen, the priorities, and how they're managed. That's what I think.
Oh, it's my turn then. Reducing time to launch without sacrificing your quality or your flexibility. Yeah, that's fundamental here. You're right, requirements first. So locking in those mission critical requirements early to avoid any scope creep. That's number one. Number two, you're going to go straight into design validation. So you're going to use product validation, simulation. You're going to simulate, iterate these rocket designs into weeks, not months. And then I think third, penultimately, it's going to be implementing lean manufacturing principles across their assembly lines. Again, keeping that speed, time to launch going. And then I'm going to bring AI in. So, because AI, I think, is fundamental here for simulation, that generative AI model. So you're going to simulate millions of launch scenarios. You're going to need AI to do that kind of variability, optimizing your designs and reducing your testing cycles by potentially 30% using AI. That's what I do. Requirements, product validation, simulation, lean manufacturing, bring your AI in on simulation. Boom.
You're on track. Something as expensive as a BFR, it's going to be something that if stuff goes wrong, it can be costly. So that I think that's where your simulation really is important in this sort of thing as well. Yeah, you got a good point there.
Yep. Yeah. Do you think we can add BFR to our acronym dictionary at work here at XDI? I think we should.
I think it already is.
Yeah, it probably already is. Big news for F-16 pilots. The U.S. Air Force is rolling out spatial audio in cockpits. And this is a game changer, guys, for safety and performance. I mean, with spatial audio, pilots are going to be able to respond up to 1.5 seconds quicker to alerts. That may not sound like much, but in a fighter jet, that could be a pretty big difference, right? The difference between whoo and which, who knows? But for those of you who understand how this tech is working, it's separating the audio sources like voices from wingmen or air traffic control. So pilots know who's talking, where it's coming from. There's less confusion. Active noise reduction is cutting out background roar, really kind of letting pilots focus on the sounds that matter. And then spatial audio is pinpointing the exact direction of threats, navigational signals, giving pilots laser sharp situational awareness. I mean, it's not just about fancy tech, which it is fancy. It's about saving lives, boosting performance, making sure pilots have every advantage in high stakes missions.
I like how we just defined the time difference between and whoo is 1.5 seconds. I mean, that's what we learned.
Yep. Now we know.
And speaking of time, we're looking at just a 2-year process to upgrade the entire fleet of X-16s with this spatial audio technology. And, the 3D audio, I think one of the cool things about this is how it basically, by separating those sounds, it also gives it the location where you hear it coming from the right direction, so to speak. So, if you know the tower's that way, you hear it coming from there. If you know your other pilots are over here. So it kind of helps with that, the brain know where these things are coming from, where the signals are coming from in space. And that's really cool. The thing for me, though, is we have software that is basically in software and hardware that have to prioritize crucial alerts, dampen secondary noises, figure out where these things are coming from, put them in the right spatial place for the audio processing. And all this has to be done in real time. And the interpretation has to be done in real time. So for me, it's figuring out the quality and the accuracy of how do you make that happen in real time and be correct. Because if a pilot is used to now the spatial location of the sound and it comes from the wrong place, that could be a problem.
Yeah.
I thought you were going with me on that one. And that little run up you gave there, I thought we were going to be in sync. I mean, I think QC, quality control, is critical, but the real challenge for me is seamless integration. You can test all you want, but if this tech doesn't actually integrate smoothly with existing avionics, the cockpit is just going to be complete chaos. You can hear frigging noises all over the place. If that's how spatial audio works, it does according to my headset anyway. Pilots rely on a unified system, not a kind of a patchwork quilt of half talking components. So for me, it's that systems integration that's going to keep that upgrade from becoming what could ultimately be a downgrade.
I mean, you said we were kind of close in line. I feel we're probably about 1.5 seconds off from alignment here, because I think you're right that you've got to have this integration. But how do you ensure that the integration is going to work? How do you ensure that what I'm talking about of the real-time processing and prioritizing the signals and processing of where those come from? It's a software challenge for both of these, and it has to be rigorously tested. Rigorously, I could speak regular. That word, tested well, because you can't have this fail. You cannot have this fail when 1.5 seconds is on the line.
True. And I agree, testing's great for quality control, but you can't test chaos into clarity without, again, seamless integration. You're basically asking pilots to juggle kind of, you're up there with a few flaming chainsaws in the middle of a dogfight. It's systems integration. You've got to make sure that everything is talking to each other harmoniously so that pilots get clear, actionable alerts instead of this kind of symphony, if you will, of mixed signals out there. So no integration, you've got no pilot trust.
But how do you know if your integration works? It's because you tested it.
Because it's freaking chaos if it doesn't.
But how do you know before it gets there, right? Like, you've got to do your quality control, your quality checking. You've got to do all of that to make sure that both your integration and what's actually happening work.
Yeah. Let's go a little bit up the process. How do we solve this? I think we start with the requirements gathering, traceability. So you've got a number one, we'd be capturing pilot requirements to align spatial as well, audio capabilities with real world operational needs. Then you're going to move it into design and change. You've got to collaborate with the terma, as I think you called it. Anyway, first time I've heard it, but terma it is, and your avionics providers to make sure that the design interoperability across of your systems is there. Then you're going to look at product validation. Then you've got your testing coming in. So conducting end-to-end simulations of cockpit operations. And then lastly, feed it back through feedback loops, etc.
It warms my soul. It's cold here in Denver, but it warms my soul to see you two arguing again. I'm very happy about it. SpaceX.
Before the show started, before Andrew joined, Greg was telling me there's like some island in Scotland where they used to send people who were arguing, and they had to stay there until they didn't argue anymore and got off. So Greg wants to have us do the show there, which requires whiskey and arguing.
Yeah.
I actually, the way you were describing it, I was going to say that's Glasgow on a Friday night all the time, but actually then you said they kind of made up at the end of it. So that's not Glasgow. Yeah.
It's not Glasgow. Yeah. They need to head up to that island. SpaceX has That's right. Has pulled off another successful launch over the weekend, sending a classified payload of satellites into orbit for the National Reconnaissance Office. Here's how it went down. The Falcon 9 rocket lifted off from California's Vandenberg Space Force Base, I think at 3 a.m. Eastern time, which was 11 p.m. So it was barely on under the weekend, but it was 11 p.m. Friday. The mission, known as NROL-126, carried an undisclosed number of satellites designed to support U.S. national security efforts. Details? They're classified, of course, but the NRO missions typically enhance surveillance, intelligence capabilities. This launch is all about keeping an eye on things that matter. What specifically that is, I'm not 100% sure. The Falcon 9's first stage returned to Earth, landing perfectly on a drone ship in the Pacific. Another win for reusability and precision. I mean, SpaceX is just continuing to cement its role as the go-to for sensitive government payloads, proving once again that it is the MVP of space launches.
Yeah, so challenge for me on this one's all to do with the NRO. It's that integration and utilization of the data once they're up there. So launching the satellites is cool, but if that intelligence doesn't seamlessly integrate into the defense systems that it's been put up there to communicate with, and the decision-making tools are there in real time, it's just going to be a bunch of space junk that's up there. So that's, for me, the number one. The bottleneck isn't the rocket or the payload. It's making sure that data is reaching the analysts back on Earth fast, clean, making sure it's actionable data.
Secrets. Too many secrets. Have you seen Sneakers? Great 1990s movie. If you haven't, go watch it. But anyway, Too Many Secrets was referenced there. But so we're looking here at the largest government constellation to date. And this is showing a move to smaller, low-cost satellites for the intelligence gathering. A lot has to be considered here. I think the launch itself, while is a challenge, is the lesser of all the challenges. I think I'm going to actually have to agree a little bit with Andrew here. Sorry, Greg. And say that the data that has to be delivered is going to be the biggest thing. It's got to be delivered fast, within seconds, within minutes. It's got to be reliable. It's got to be accurate. I think figuring out that data gathering and delivery is actually the biggest challenge here.
Yep. We're on the same page. I mean, it's useless if it doesn't integrate and it doesn't drive decision making in minutes, not days. That's the bottleneck. That's the trick here. You got to deal with that data, get that operational, get it coming back to Earth.
And it's not just the data gathering that has to work. It's also figuring out, in order to gather the data, these have to be deployed into the right orbits and the right positions, has to do all the calculations of where things are when they're gathering data. And it's got to make sure everything is working correctly in this environment where, can they self-repair, or do you have redundancies? What happens when things break? And all of that has to be done in order to collect the data and send it back home. So for me, to get all of that to work, I think it's going to be mostly a look of what are our requirements and did we test correctly. And Andrew's going to say something different.
I'm with you, man. I'm with you. It starts with requirements. Absolutely right. Making sure you've got those payload requirements matched into the downstream defense systems that they need for real-time use. So I think you're absolutely right. Requirements. I think then if we go on in our critical threat and how we solve it, we've got to have a good design and change management solution in there, making sure standardized data protocols into the payload designs to make sure you've got simplified handoffs post-launch. And then you've got your product validation. So you've got to be able to test end-to-end data flows from satellite transmission to intelligence platforms presumably back on Earth or in the cloud. Yeah. You're going to say.
I was just curious if what Greg thought about the fact that we seem like we're in the same orbit here.
Again?
Yeah, it's getting to me a little bit. So I'm gonna need to think about this. While I'm thinking about it, is there anything we can do?
Ooh, you a Tylenol?
I think what he's saying is, are you saying now might be a good time to take a look at some of the other headlines that we're not talking about this week?
I think it could be. Now's you. Airbus is on the
one of those headlines we could just rename to "Meet the Fockers."
That's
yeah.
It should have been. You're right.
I'm going to go on my soapbox here, and I've been talking about it for quite a long time, which is how long it takes us to get from design to customers' hands in defense, which is way too long. They just announced that hypersonic JV, UK, US, I think Australia was in there as well. I am intrigued to see from last week how long it takes them to get it out there. Is it 2-3 years like the Chinese do, or is it 5 years because of compliance and red tape and blah 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 blah? I am throwing the gauntlet down. They probably don't care, but I'm going to do it anyway. Number two, Starlink competitor. Interesting. That would be a true test of, is it best to be first or best to be best? Whatever that meant.
Or best to be first and best?
Yeah. So will they be able to compete with Starlink? That's going to be interesting.
Do they have
way ahead?
Do they have the infrastructure to get as many satellites as Starlink has? I don't know.
Maybe they're going to be using Starlink sats. Who knows?
Yeah.
What are the rules against a competitor putting up their own satellites and then attack the other satellites?
Now that sounds like an exciting show.
Star Wars.
Okay. Yeah, it's like BattleBots, but battle lights.
I don't know what happened up there. It just stopped working. Yeah.
That's great. Saab has unveiled the Ground Combat Indoor Trainer, a cutting-edge virtual training system for its suite of ground combat weapons, including the Carl Gustaf M4, AT4, and NLAW. Here's what makes this development noteworthy. This is realistic training. The GCIT is employing advanced technologies to create highly realistic training scenarios, enhancing soldiers' preparedness for actual combat situations. It's cost-effective. Allows for comprehensive training without the expenses associated with live fire exercises. And anyone who has gone to the range knows how expensive 5 minutes of the range is, right? Versatile configurations supporting both individual and collective training, accommodating various weapon types, small arms, large, meeting some pretty diverse training needs. And really, they're just showing this off. This is just showcasing for the first time that Saab did at the Inter-Service Industry Training Simulation and Education Conference, or ITSEC, I think it's called. I don't know, in Orlando. But that's cool. I mean, that's some cool technology, and I think it's needed.
Oh, it's super cool because this is like, I want one of these in my living room, right? Like, talk about a nice little, who needs the Wii when you can play this, right? But
it's true.
It's supposed to be virtual weapons training for all of their weapon systems. So, like, being cost effective, great, makes sense. Fantastic way to prepare soldiers. If we learned anything from that movie, The Last Starfighter, if you haven't seen it, go watch it now.
I don't think you could learn anything from The Last Starfighter, but carry on.
You just haven't seen it. It's fantastic. That is my argument where I'm going to say Andrew is 100% wrong in this show, as he does not think it's a good movie, because it is. But the biggest thing for me in all of this is making sure that this is accurate to real life situations, not just the scenarios, but also the way that the weapons feel, the way the soldiers have to react to them, the environment. All of this needs to be a very realistic training in order to make it appropriate in real life situations.
Yeah, I kind of agree, but I think there's more to it than just the realism aspect. The real challenge for me is adaptive training and scalability. Soldiers have all got different skill levels, and the system needs to dynamically adjust to train both beginners and seasoned operators effectively, because without that scalability, it's risks being a one-size-fits-none solution that doesn't meet the demands of modern, diverse military units. So it's got to be adaptive. It's got to be scalable.
I mean, I'd argue that if it's realistic training, it's going to actually be able to fit into exactly what you just said, of being able to have the situations of the soldiers, their different skills, everything that's going on with them, be something that actually makes sense in the training scenario. So I think they need to take the training software, test it against real life situations, real life physics, and real life skill sets of the people who are using it, and trying to make everything as, again, real as possible.
So you've kind of merged with me a little bit there, but if realism is your holy grail, you're kind of ignoring the fact that the real combat situations, it's not a static environment. Soldiers need training that's going to adapt to their skill levels and challenges them in dynamic ways as those skills continue to evolve. So without that scalability, even the most realistic system becomes basically a glorified simulator for beginners.
I mean, that is a fantastic point, because you can't have a training system that doesn't train you for the actual situations, which is why I was arguing for real. But real means to incorporate the fact that, as you say, the combat isn't static. You've got to be ready. You can't just know like the cheat codes to get through the game level, because you know it's going to be set. It's going to change. It's going to have to change. And how do we figure that out? How do we make something like this kind of training, as realistic, by my words, as possible? And I think it's going to have to go back to looking at what are we trying to do with this. So we start with what are the requirements we're trying to get, is figuring out what we're training for.
Yep. So you just say requirements gathering, then your design and change comes in. So you've got to develop a modular simulation framework that's going to be able to adjust to difficulty and complexity dynamically. You're going to need your product validations, your simulation layer on top of that. So you've got to have test scenarios with real soldiers to gather feedback on the realism, to your point, and the scalability, to my point, making sure that everyone's aligned with the operational needs of that combat force.
Greg, do you remember how sometimes when we have these discussions, Andrew is like, so Bryan, you're basically saying everything? I think that's what Andrew just did. He just went from requirements to design to product validation.
Yeah, but Andrew's allowed a couple of those. If that's your default response.
I'm giving a total solution here.
Right, everything.
Yeah, that's true. It kind of reminds me of the flight simulators that they used in, well, I mean, we all know movies can be a little exaggerating, but in Sully and he's like, yeah, like
the last Starfighter. It was a great one.
In Sully, because they're like, all of our pilots who were in these simulators could do what needed to be done. Why couldn't you do it? And they weren't thinking of they weren't putting the human response time in there. They were saying, yeah, this is what we do. We get hit by birds and we just automatically turn. That's not how it works. So anyways, it's interesting. There's a lot of things going there. Safran's chief technology officer has indicated that if aircraft manufacturers aren't keen on the open fan design of the RISE, which is Revolutionary Innovation for Sustainable Engines program, its advanced technologies could still be applied to traditional ducted fan engines. Here's the breakdown. There's flexibility in design here. So RISE innovations, you can kind of see it there. Program innovations are versatile enough to enhance both open fan and conventional ducted fan engines. That's a mouthful to say, offering manufacturers some adaptable options. There's some big cost considerations here. Implementing RISE technologies in a ducted fan configuration could be far more cost effective, making it a more attractive choice for some airframers. And then Safran is actively testing components like low pressure compressor with a 6-month trial to begin in early next year, which is only a couple weeks away. There's a lot. Like, I love how much they're leaning into advancing engine technology here.
I think you've touched on it already, which is design flexibility is going to be, that's the real challenge for them. And that RISE tech is going to need to balance the versatility across an open fan and a ducted fan design without creating delays or unnecessary compromises. So flexibility, it sounds great in theory, it sounds great in the press release, but if they can't execute without slowing production, maybe that was my Sean Connery impression. Wasn't good. Slowing production or inflating the cost, then those innovation risks are going to be really grounded before they even take off. So that's it's good to say it, but delivering it is the biggest challenge.
So what I heard Greg say in this news recap was, here we have some technologies that could be used in multiple scenarios, that could be cost effective, that could be a more attractive choice for airframers. That's a lot of coulds. The only way we know if this is actually something that is true is going to be to test it against the use cases, the requirements, try it out, and use those results to modify the design if needed to make sure that it can be flexible, be cost effective, and be an attractive choice.
So testing. Okay. Yeah, but without that design flexibility really, really baked in from the start, what are you going to be actually testing? You can't iterate on something that's fundamentally too rigid in the first place to adapt. So you're going to be test driving basically a car without a steering wheel, hoping that it goes in a straight line. So I think it comes back to the fundamentals of that design flexibility is the biggest challenge. I rest my case. Thank you. Move on.
So I gotta say, this design looks pretty cool. Open fan architecture, the turbofan flight speeds, the compact core, the combustion tech, the hybrid electric capability. But I'm still going to stick with testing. Does it work? Does it hold up? And does it replace the traditional ducted fans? I think the only way you know this is by actually testing and seeing those results.
You stick with your test results, Bryan. You stay there. I'll make sure that Safran has got its designs worth testing in the first place. Okay, I'll hand those over to you. Flexibility isn't a nice to have here. It's the backbone of turning the possibilities into an actual solution. So enabling design flexibility to support rigorous testing. Bryan, he's over there. Okay. Without delaying development. So number one solution we're going to employ here is requirements gathering again, collaborating with your airframers to define use cases for both configurations up front. Then we're going to go to design and change. We're just going to go through a pathway here, gentlemen, our journey.
Would you call it the critical path?
The critical path along the digital thread, aka the critical thread. Implementing parallel design paths to support iterative changes based upon emerging requirements. Then you're going to simulate. Then you're going to get your operations monitoring for your feedback loop going. And then we're going to bring in, what's it going to be?
Unintelligent artificial. No.
Artificial intelligence to analyze that test data, because you're here again now, and recommend optimal design adjustments, ensuring that your flexibility supports the reliability. So,
see, Greg, did you see that? He circled all the way back around to where I started testing.
He did. Yeah. It's impressive.
You wanted the number 1 challenge, not the number 7 challenge. That was the difference.
That's true. And I know you were channeling your inner Sean Connery there. Was that because you want to argue and go to Scotland and have a debate on an island while drinking whiskey?
Show, isn't it? Scottish
Sounds
show.
Like it.
Yeah. I think HR should send us there.
Yeah.
Okay, I'll have a conversation. General Atomics Electromagnetic Systems has secured a contract from the U.S. Navy to advance its long-range maneuvering projectile round, awarded via Advanced Technology International under the Naval Surface Technology Innovation Consortium's other transaction authority. This contract is aiming to mature and demonstrate the LRMP, long-range maneuvering projectile prototype for the Navy's offensive strike missions. The LRMP is designed to engage both stationary and moving targets at distances exceeding 120 kilometers. That's massive, quadrupling the current reach of conventional artillery systems and scalable for use with existing 155 millimeter artillery systems. The long ranges integration with legacy launchers, autoloaders, and handling equipment will be huge as well. Preparations are underway for glide testing at Dugway, marking really a significant step in validating the LRMP's capabilities. This is kind of crazy.
It's crazy. It could potentially be one of those weapons of the week we like to talk about once it gets there. But right now, we're looking at something that could possibly go to manufacturing in 2026. It's currently a contract to develop for now, right? So it's still got to get through the testing you're talking about. The idea of defeating targets, even moving targets that are 75 miles away, is pretty impressive. That's a long way, and being scalable to use in all the existing artillery systems, the legacy launchers, the legacy autoloaders, all of the equipment that's already there. That is a design requirement that is impressive, because for me, that integration, being able to figure out how do we make sure that this new tech, this new weapon of the week, so to speak, works with all of the existing old legacy stuff. So integration is the biggest for me here.
No. I can't agree with that. The real, you've said it yourself, 120 kilometers. Accuracy for me, it's range to accuracy optimization. 120 kilometers away, any deviation from that intended target could just render the entire effort ineffective. So developing a system that balances extreme range with pinpoint accuracy, that's got to be the real hurdle, guys. Come on,
Andrew. Pinpoint accuracy at extreme range is fantastic, but what's the point? What is the point if the projectile that has this accuracy, has this range, isn't able to launch from the systems it's supposed to launch from because the integration wasn't figured out, wasn't done correctly? Integration is the fundamental thing here. You can't hit something if you can't get it to launch in the first place.
There's an old English saying, which is
there?
Yeah, there is. Cart before the horse, buddy. If this projectile can't hit its target at 120 kilometers, it doesn't matter how many legacy systems that you've fitted it into nicely, hand in glove. It's just an expensive way to miss. So range to accuracy is the make or break challenge.
I mean, we can argue, the chicken or the egg as much as we want here, but I think if we want to figure out a solution, how do you make sure that you have something that is accurate, have something that is integrating, that does all of this?
Yep.
Basically means we're going back to where we seem to always go back on this show, is figuring out those initial requirements and how we make them work. I
think the requirements are done, man. I think they're done.
Yeah.
Hit that shit 120 kilometers away, okay?
Can we get that t-shirt for the show? Apparently just hit that shit.
So it's design and change we've got to get right here. Immediately develop modular designs to streamline compatibility across legacy artillery systems and optimize your material usage. Then you're going to have your validation, your simulation. We're going to put that in there. And then and then your AI is coming in here on design and change to refine projectile trajectory calculations. I'm glad I said that slowly, based on real-time environmental data, in making sure that you've got optimal accuracy at maximum range.
Now, did you hear about the guy that walked in to a bar and ordered a drink? The bartender's like, "You've had so many. Are you drunk?" And the guy pauses and says, "I don't think I am." And he disappeared. Now, that joke's not funny, but if you knew the prerequisite about this famous philosopher, Descartes, who was talking about like how, that phrase, "I think, therefore I am," well, then the joke makes sense. But if I'd said it in that order, I would have been putting Descartes before the horse.
Wow.
God, that was gone to a commercial break.
No, that was beautiful. I thought that was great. The one thing that I'll add is I don't know that this needs to be like, it's maneuverable once it's in the air. It wings pop out, so it could if you needed to adjust maybe halfway through. I don't know. I'm not sure. I don't know how it all works.
So what Andrew's saying is you've got to have the integration to launch it, or sorry, what Greg was saying, you have to have the integration to launch it in order to have it launch, and then it can correct itself afterwards. So integration is the most important. Thanks, Greg.
Sorry, Andrew. BAE Systems has recently wrapped up a successful in-water demonstration of its Hearn extra-large autonomous underwater vehicle off of England's south coast. Here's why this is a big deal. This thing is built for anything. I mean, this is a multi-mission powerhouse capable of handling anti-submarine warfare, protecting critical infrastructure, covert surveillance. There's a lot that can be done with this. The vehicle, and Andrew, I know you're going to get excited about this. The vehicle itself went from concept to testing in just 11 months, which is, lightning speed, right? That's That's what we want to see. Observers from 10 different nations, including major NATO and Five Eyes partners, showed up to see it in action, highlighting its international appeal. I mean, this cements, I think I'm saying it correctly, Hearn? Is it Hearn as a major player in autonomous underwater tech, and sets a new standard. Like this thing's cool. I would almost put that as the weapon of the week.
It is very cool looking. It's mean looking, that is, isn't it?
Yeah.
Really mean. So number one here has got to be that, you mentioned it, the multi-mission adaptability. Their success is going to lie in that ability to pivot between anti-submarine warfare, infrastructure protection, covert surveillance that's going on. Because if it's too rigid or it's too specialized, it's going to risk falling short in kind of the versatility it needs, in the mission scope that's going to come along. So adapting seamlessly, if you will, to different operational needs isn't just a feature of it. It's going to be the core challenge for me. Take that.
Autonomous underwater vehicle, extra large edition. Captain Nemo will be proud of this one. I mean, this is impressive, and I think it's cool that this is the first underwater trials are completed. That's a huge step, but there's more to come. Not just talk about the adapting seamlessly to different operational needs, as Andrew was saying, but I think it's all about taking the test results from these trials and future trials, figuring out what those next steps are in the design. You have a fast track design already, 11 months from concept to testing, but you still got time from testing to final design to production. There's going to be results from that test that have to be implemented with this speed, put it all in there. So I think the integration of that testing and those results into the next design and updating the design is really the next important step.
So you're going design adaptation, change management, CM is the crucial challenge, is the big challenge.
I think CM is the one for me.
Yeah. I think you're forgetting the big picture, man. I think if Hearn isn't adaptable across missions, all the CM work in the world won't save it. We're not designing a one-trick pony here. We're building essentially a Swiss Army knife of underwater tech. So without multi-mission adaptability, CM might as well be critical mess.
Now, we know that Andrew really does actually like design and change management, and you're just arguing this for the sake of arguing. But let's play along here. So you're saying we're not designing a one-trick pony. You're right. Yep. We this is something that is like I do like the Swiss underwater knife, except the fact that would probably rust. You can't have that happen. So you do have to have this, but I think it's really showing and will continue to show through this whole process that the most important area of this is change management, the proper use of CM here, integrated with that design process. I think that's how we get something in the end that is probably going to revolutionize this whole wide world of the ocean.
You can't get away from a good piece of change management. There's no doubt about it. But that multi-mission adaptability makes sure it stays relevant across decades of missions. So the critical thread here and AI, we're not just fast tracking her, and we're future proofing it. So again, I'm going to start out with requirements. You got to get that all done. So collaborate with NATO, collaborate and Five Eyes partners to make sure that you prioritize that mission specific adaptability. Second, you've got your product validation, simulation, mission scenarios, be that anti-submarine, be that surveillance, to optimize the configurations. Three, you're going to bring in your life cycle support, so building modular hardware, software frameworks, and then using your AI to dynamically configure Hearn's systems based upon mission parameters, optimizing your hardware and software thereafter in real time. Total solution.
That was a total solution, and
we got to get that. We got to be playing with this one. I mean, 11 months. I love these guys.
Yeah, that's pretty impressive. That was almost as fast as one of our commercial breaks. Every time we have these and just run through these list of headlines of the stuff that we're not talking about this week, it always fascinates me and reminds me how big the world is. I mean, there's so much happening that we tend to forget about, and it's crazy. Yeah. Like, and there's, conflicts that have been happening for years and years and years that are still driving development and technology and all this kind of stuff. It's fascinating.
It's pretty big. It's not, obviously it's noticeable. A lot surrounds that whole Ukraine piece, and then obviously Middle East. You've got South China Sea. You've got that whole Korea thing going on. But I mean, India as well. They're just doing stuff, aren't they? They are. Powerhouse military force coming through.
Yeah. And we think about everything that's going on the ground and how much space there is in space, literally. Like there's a lot of room. It's good. Yeah, there's a lot of space in space. So as I think say what? What?
That's where the name came from. Yeah.
Oh, brilliance, I tell you. whoever said that. As we discussed, and I say we, as in I think the two of you discussed this last week, NASA is advancing its Artemis program by assigning lunar cargo missions to SpaceX and to Blue Origin, aiming to establish a sustained human presence on the moon. I'm sad that I missed it last week, but I'm excited that we're talking about it again. Both companies are tasked with developing cargo variants of their human landing systems to deliver substantial payloads, 12 to 15 metric tons to the lunar surface, which is that's a lot. These missions are going to transport essential equipment, pressurized rover, surface habitat, facilitating extended lunar exploration and habitation. The cargo deliveries are scheduled for the early 2030s, aligning with NASA's goal for long-term lunar exploration. I mean, to have a human presence, a sustainable human presence on the moon, is just kind of paving the way for future Mars stuff, right? How do we get stuff to Mars? Well, let's start on the moon. Baby steps, right? It's good.
Are you ready for a house on the moon? Yep. I mean, I think this is taking the idea of a mobile home to a new stratosphere. There's a lot to consider over the next 5 or 10 years in order to be able to do this. I think we've had these dreams of bases on the moon, people living on the moon for years. But the fact that this could actually become a reality within our lifetimes, not only that, within the next decade, is mind-blowing. What's the most important thing here? Is it the design? Is it the safety? Is it the testing? Is it the requirements? For me, and I know that Andrew's going to argue something different just out of spite, but for me, the biggest one, the number one here, is going to be to make sure that we've got a cost-effective and safe way to carry huge payloads to the moon. That's the only way this is going to happen, is if you can take a lot of this stuff up at once. And just to put it into perspective, you said, 12 to 15 metric tons, right? Like, I think an elephant's like 6 tons or something. I mean, that is a lot just being taken up, being launched off the ground into space. So for me, to get all of that to happen in a cost-effective way is going to be all about the design and the innovation. We're doing something that has never been done before now.
There's no doubt this is a challenge. I actually was going to say the biggest challenge here is getting Greg out of his slippers and his blanket in front of the fireplace, so feeling safe.
Here's the thing.
You have a house on the moon?
Yeah, no, I would 100%. I don't understand
an autonomous bicycle. Never mind that.
I was just thinking about that. I was like, why would I be so worried to get into an autonomous vehicle or an autonomous drone that's going to carry me somewhere? But when it's like, you want to go to the moon for a week or two, or buy a house on the moon, I would consider it very much so. Yeah.
Double standards, man. But let's get back to the main thing here. Design and innovation, you say, is your biggest challenge. Yeah, that's a good, relevant one. But it has to be the fact that you've got a supply chain in play here. So your number one challenge is the supply chain and your logistics optimization. This isn't just about getting payloads to the moon. It's about ensuring every piece of equipment, from pressurized rovers to habitats to 3 elephants, as you were talking about. Where the elephants come into this? I don't know. What are you talking about? Arrives on time, intact, still breathing, big nose bag, lots of food, and in the right sequence. without solving your supply chain and your logistics optimization, even your best designs will become your logistical nightmare.
I love how somehow me using elephants just to put how much weight this is into perspective has now opened up the idea of like a zoo on the moon. But hey, I'm here for it. Okay, so, but logistics only matter if you've got something to transport. They only matter if you've got the design of how you're transporting it into place. So in this case, I think figuring out that design in the innovation of how this is happening is actually more important than the supply chain, because you don't exactly know what you're supplying yet, what logistics you need to supply until you've figured out what we're transporting, how we're doing it, what's going up there. So you've got to have a landing system that can safely carry and land with the payloads. You've got to have vehicles that can transport all this stuff safely. No amount of scheduling or sequencing is going to save the mission if you don't know the designs figured out first. This is, again, the foundation here is design and innovation.
It's typical designer, isn't it? I mean, you'll be spending hours and years designing the perfect car, but forgetting you do need a road to put it on. Okay? That's the designer. That's the engineering you're doing that, I believe. So without an optimized logistics system, we're just piling rovers and habitats and elephants into a lunar junkyard. So your supply chain, your logistics optimization ensures that every delivery makes sense and serves the mission, not just the headlines of a cool looking vehicle.
Ladies and gentlemen, listeners and friends, all the designers and engineers out there, I would like to sincerely offer my heartfelt apology for the offense that Andrew Sparrow has just given to all of us in the design world. It's an apology we're extending from the depths of our hearts. This is a PSA, and I just want you all to know.
We weren't talking about manufacturing, isn't it? I'd have been really going at it. So for me, establishing a logistics framework to make sure you've got timely, you've got safety, you've got efficient delivery of that payload, whatever that payload seems to now be in the zoo on the moon. Number one is define that payload sequence and mission critical equipment priorities with NASA. Get your supply chain management integration solution in place. Hello, that's us. Develop your lunar specific logistic workflows, including your launch timing, your cargo handling, and your surface deployment strategies. And then get your testing done. So you've got a bit of digital twin stuff going on. And then overlay your AI to dynamically adapt launch and delivery schedules based upon those kind of real-time conditions that you've already got in that system, including your weather, including your orbital dynamics, and resource availability. There you go.
Did you hear that, SpaceX and Blue Origin? We are not going to be satisfied with this project until there is a zoo on the moon that has an Airbnb that Greg can go stay in overnight.
That's correct. And I would like to add to that, this is me letting NASA know that if they need a caretaker or a zookeeper or whatever, an owner of the menagerie, I would be very happy to put my application. Sorry, Andrew. I'm going to put my application toward being a zookeeper.
That'll be the extra 20 hours a week.
That's okay. Right. Yes. Yep. Exactly. Yeah. As long as they're okay with me, commuting back and forth a little bit.
Yeah, a little bit of a commute or a remote work from home there.
That's right. That's right. Boeing is ramping up production of its MQ-28 Ghost Bat uncrewed combat aircraft. Look at that thing, with a new facility in Toowoomba, Queensland. A couple different things about this facility details. It is a 9,000 square meter plant at the Wellcamp Aerospace and Defense Precinct. It's Boeing's first final assembly line outside of North America. That's a pretty huge deal. Yeah. Construction has already begun with it. Facility itself expected to be operational within 3 years. And then really this venture is going to help boost the Queensland economy, bringing advanced aerospace manufacturing job opportunities to the region. I mean, the Ghost Bat, as we see here, designed to operate alongside crewed aircrafts, represents a significant advancement in autonomous military aviation. This is huge. Like to see, and we talked about this with, I think, helicopters a few weeks ago, but to see kind of the in tandem uncrewed and crewed aircraft working together, there's a lot going on here. It's good.
Yeah, I think we're getting pretty knowledgeable on these unmanned aerial aircraft right now. We've got a lot going on in that defense space from an XD perspective. But the biggest challenge is going to be scaling production capabilities, delivering the quality, meeting the deadlines. Ghostbat is as cool as they come. It definitely looks that. But that new facility is going to mean ramp up challenges. It's going to ensure supply chain continuity to make sure you can fine tune those production workflows. So without that scalable process, this kind of on track status could really derail quickly. So they're going to have to nail that scalability in there.
I mean, scalability and being on track is certainly a good sign. But what I want to focus on is we've got a new facility for final assembly and a large new facility for final assembly being made here. This means we get a look at the area of the actual design of the plant, plan for manufacturing in this design. We know what's going to be built here. So you get a plan and figure out exactly how is this going to work? How is this going to integrate into my entire manufacturing process? I think this is a really cool area to look at, and it saves money in the long run when you take that time during your building phase to figure out how is this going to actually work with my execution.
You just can't get him out of design, can you? So if he's not designing an aircraft, he's designing a plant now. Planning, theorizing is great, but execution is everything. If you don't have a scalable production foundation, you're just building a high-tech sandbox out there. This Ghostbat's success is going to depend on those scaling processes. It's going to be to handle that demand, those deadlines. And yeah, plant design is all part of it, but production scalability is really the end game. Otherwise, you're just going to have a kind of a pretty expensive showroom on your hands.
Are we really living in a world where I'm the one who's about to talk about how cool Mess Mom is? I mean,
it makes sense
because you're right. Like you got to scale, but the production here, being able to design your production facility with your manufacturing, your Mess Mom all in mind is huge, because you can figure out how you're actually integrating your all your real-time tracking, your real-time inventory management, all of this stuff into this whole scalable production. I think Mess Mom is the most important thing to look at here.
I totally agree. It's the most important solution. I don't think it's the biggest challenge, but let me come on to the solution. I think I'm going to pull in your challenge here, which is getting that kind of digital twin of your production processes. So you simulate, you optimize that scale up scenario. So I think that's number one solution. Number two is, yes, your Mess Mom. You've got to have Mess Mom. You've got to have it connected to your lines so you can introduce your PDCA cycles. So you've got that continuous improvement going on, because they ain't going to get it right first time in terms of optimization. That PDCA cycle stuff is going to help get them there. That's going to then loop into your Mess Mom framework so that you're optimizing your workflows, minimizing waste, getting it kind of right first time, all of these good things. And then leverage your Mess Mom also for preventative maintenance. So you've got your AI coming in on preventative maintenance to make sure your downtime's minimized. Get all those things together. This is fun. Let's go to ours. Let's go get it done with them.
And that brings us to our second catchphrase created for the day, which is, yes, you Mess Mom.
It's perfect.
Okay.
I feel like we do need to start designing these, but we'll get there.
It'll be in our Etsy store later.
Yeah, that's right. That's right. Bombardier Defense has delivered the first Global 6500 aircraft to the U.S. Army for its high accuracy detection and exploitation system program, Hades program, for those of you that have been following along with all of our wonderful Greek-themed acronyms. It's great. The Global 6500 offers superior speed, range, and altitude capabilities, which really is going to enable some pretty advanced intelligence, surveillance, and reconnaissance operations. This delivery is marking a huge step in modernizing the Army's aerial intelligence assets Of course, replacing older platforms with more capable and updated technology. I mean, the ability to operate in a handful of different and diverse weather conditions, extending endurance of it, it's going to enhance that mission readiness and effectiveness of the Global 6500. It's a lot.
So the first one is delivered by Bombardier that's now going to be sent to S&C for conversion to Hades. So there's a lot going on here, right? So Bombardier has got to make 13 more Global 6500s, but S&C has to convert them into all of the stuff needed for these to be part of the Hades program. So I think that manufacturing is a challenge to get 13 of these out, but I think the conversion is actually the bigger thing to look at here. What are we doing to this cool aircraft to make it into something that really hasn't been made yet before? So I think I'm looking at the requirements of the conversion and how does that happen?
You're always safe when you go requirements, aren't you? Really,
they're important. One might say they're required.
You're just surprised he's not saying design.
Be comfy, safe requirements.
No, design is my safe zone, Andrew.
No, and if you're not sure, you can go requirements. I know your game. I get it. Get off the fence, buddy. Integration testing and validation. This is about turning concepts into operational capabilities. The Hades conversion, it's not just a checklist. It's an iterative process they have got to go through to make sure that every system, from ISI tech to comms, it's got to work seamlessly under real world conditions. So that integration testing, validation, it is number one.
So what you're saying is you need to have your requirements and your integration and testing all part of the same feedback loop, which is
what I'm saying.
No. 100% correct, because the 6500 gives us range, payload capacity, speed, endurance. The next step is the timely, relevant, and responsive capabilities for the full spectrum of the joint collective requirements of the Army here. That's the rub. It's all about the requirements of this thing for Sierra Nevada to be able to meet.
Requirements without that whole kind of integration testing and validation. You got the world's best recipe, but with no stove.
It's a well-oiled kitchen machine. The requirements and integrated
with no stove.
Work together.
With no stove, you've got to be able to test and refine in the real world to make sure that your requirements translate into actionable capabilities. Otherwise, the Army's going to be getting a flying science project that's not a mission-ready system.
And how do you know if it's a mission-ready system and not just a flying? I'll give you one guess, Greg. How do you know it's a mission-ready system? It's if you meet your
design. Sorry, we can't hear you. Greg, you're breaking up. You're breaking up, Greg. How do we fix it? Number one,
requirements.
Map out your Army's requirements. Then you've got your design and change. So we're still in Bryan's wheelhouse. And then we're going to go AI, aren't we? We're going to analyze those integration tests using AI. We're going to flag any discrepancies, recommend adjustments to streamline that whole validation process, overlay that root critical thread. We got you.
For anybody who needs a recap of today's show, I think there's a couple things.
It was called Bryan's Wrong and Andrew's Right. That's it.
It was called Your Watch List for the Weekend is now the entire series of Space Force, the movie The Last Starfighter, a Sean Connery playlist. Let's go with Entrapment and 20,000 Leagues Under the Sea. That's what we learned from today's news. And we have our 2 new slogans coming out soon to a store near you, going to be Hit That Shit. Yes, that was quoted by Andrew. And yes, you mess, Mom. I mean, that's what we've learned. Any other strong takeaways from the show, guys?
No, I think you got it. Other than elephants on the moon, as I say.
Oh yes, right. Elephants. We need the elephants on the moon.
And my application for caretaker. Just
yes. Yeah. The zookeeper. Everybody, thank you for joining us. Have a fantastic rest of your week, and we're out.
See you next week.